Hi everyone, today we're going to talk about giant structure. And the learning objective of today is to describe the giant covalent structure of graphite, diamond, and silicon dioxide. Also, we need to relate their structure to the use of graphite as a lubricant and of diamond in cutting. Okay, the first thing is, let's take a look at this table that compares all the different parts of diamond, graphite, silicon dioxide. So here are two pictures of what they actually looks like. So diamonds very shiny, some of us have seen them before, and graphite is usually has been used in pencils, so the lead in the pencil is actually just graphite. They are both made up of carbon, a very simple element in universe, but one thing special about them is that their structure is very, very different. So if you were to use a super magnifying glass to take a look at their structure, diamond will have this giant, really complicated structure, and graphite will have this really weird structure as well. So let's take a closer look at their structure. Diamond will have a structure that every single one of the carbon will reach out to 4 other carbons which is adjacent to them, and that forms strong covalent bond. And the melting point will be very high as well. Graphite, on the other hand, each of the carbon will be reaching out to 3 other carbons, and they will form a sheets of these layers, and there will be very weak bond between the layers, but strong bond inside of the layers, which is also covalent bond inside of each ring. And that is why we tend to use graphite as a lubricant, because each of the layers, in between the layers, because of this weak bond, the layers tend to be able to slip off of each other. So when you feel it, it's very slippery, and then graphite can be a lubricant. And on the other hand, because diamond has this very strong structures, and it will be really hard for the diamond to change its shape, and diamond itself is really hard as well. And that's why we use diamond to cut every other things. In silicon dioxide, the structure looks very similar to diamond. It's just they will have 1 oxygen being inserted in between 2 silicon atoms, and the melting point is really high. In silicon dioxide, it's a very hard structure. It's a very hard compound as well. So it has a really strong covalent bond. Now let's take a closer look at how we relate melting point to their structure. We talked about what is melting point and what is boiling point before. Melting point is a point that all the solid will break away from their position because they have gained enough energy and they are able to move around to become a liquid. And boiling point is a point that liquid will gain enough energy and they will break free from each other and they will tend to form gas. Now let's take a look at our special structures over here. Because of the strong covalent bond that they have in between each of the element, they will need a lot more energy than the other structure to have their element to be break free away from each other. So they will need a lot more energy, and therefore their melting point and boiling point will be very high because they will need more energy to break away from their position and to break that covalent bond in between each of the elements. What about carbon dioxide? Doesn't carbon dioxide also have a very strong covalent bond? And why doesn't carbon dioxide has a very high boiling and melting point? Well, that is because in between each of the carbon dioxide molecule, there's hardly anything. So basically, there's no covalent bond in between this carbon dioxide and this other carbon dioxide molecule. So you don't need much of an energy to bring the carbon dioxide into liquid form, and you even need much of an energy to bring this carbon dioxide into gas form. Now, we're going to talk a little bit more about graphite. We talk about in diamond structure, the carbons in diamond will reach out to 4 other elements, right? And in graphite, you will only reach out to 3 other carbon elements. Well, that's kind of special, and it sounds really suspicious. Isn't that in carbon atom? We learned that in last semester. Carbon has atomic mass of 6, and you will have 2 atoms in the inner circle and 4 valence electrons on the outside circle. So they tend to form 4 covalent bonds. So does that mean that if this carbon forms three other covalent bond with three other carbon, then it actually has one valence electron, doesn't even need to do anything. And same thing goes on with every single one of the carbon element. Well, that is true. So that's why in between the carbon layers, you will have this free electrons that belongs to every single one of the carbon that they can just move around. That's why we can use graphite to make a conductor. And that's why we can use graphite to make this amazing maze solver. That's it for today's lesson, and I will see you next time.